Hello friends, today we will discuss about this problem. All the cases you have to calculate magnetic field at O point. So how to calculate this magnetic field? By using Biot-Savart law, you can easily calculate the magnetic field at O point. So how to apply this Biot-Savart law? All of you know that if you apply a Biot-Savart law for this current carrying conductor, suppose this is a current carrying conductor, this current carrying conductor carrying a current I. Now you have to calculate the magnetic field at a distance d from the current carrying conductor. This point is O. So you have to calculate the magnetic field at O point. So this is the, suppose if I take this angle as theta 2 and this angle is theta 1 along this direction, it is along this direction, then magnetic field at O B equals to mu 0 by 4 pi I by d into sine theta 1 plus sine theta 2. You have to mind it that we have taken theta in this theta 1 in this direction and theta 2 in this direction. Now if I want to transform it by these two angle, so what will be the formula of this magnetic field? So here, what is the relation between theta 2 and alpha? This is theta 2 is theta 2 plus alpha must be equals to 90 degree. So it will be theta 2 equals to 90 degree minus alpha, and also theta 1 can be written as 90 degree minus beta. So if I want to transform this equation in terms of alpha and beta, then sine 90 degree minus alpha equals to cos alpha. So it can be written as mu 0 I by 4 pi d into cos alpha plus cos beta. This will be cos alpha and this will be cos beta. Now if I taken that this is a current carrying wire and you have to calculate the magnetic field at point O, So suppose how to calculate this? What will be the relation? And this is the point. This is the perpendicular distance d. Now this angle is theta 2 along this direction. And what will be the theta 1? Theta 1 will be along this direction. In first case, I have taken theta 1 is along this direction. So in this case, theta 1 will be negative. So for this case, this magnetic field will be B equals to mu 0 I divided by 4 pi d into sine minus theta 1 plus sine theta 2. So it will be mu 0 I by 4 pi d. This will be minus, so sine theta 1 theta 2 minus sine theta 1, because sine of minus theta equals to minus sine theta. So it will be the equation. So these two form are very important. to calculate the magnetic field in various cases. Now, if this point becomes here, then both the angle theta 1 and theta 2 will be 90 degree. If I move this point, in this case the angle will be greater. So theta 1 and theta 2 will be 90 degree if this point moved at this point. So if you want to calculate magnetic field from a wire along the direction of the wire at this point or at this point, the magnetic field will be mu 0 I by 4 pi d, and here it will be sine 90 degree. So sine 90 degree 1, and this also sine 90 degree. So this is 1 1 1 0. So it will be magnetic field will be 0. So at this case magnetic field will be 0. So this is the main fundamental things to calculate the magnetic field in various cases in this formation. So this is the main thing. By using this formula we can calculate magnetic field easily. Now, magnetic field is a vector quantity, so it has magnitude as well as direction. So how to calculate the direction of this magnetic field? See, by Sapar law we can write that mu 0 by 4 pi I dl cross r vector divided by r square. This is I. So this will be r cube, because this is r vector. So mu 0 I dl cross r vector divided by r cube. This is the Biot-Savart law. So using vector product we can easily calculate the direction of the magnetic field. So how to calculate the direction of the magnetic field? So this is I. So suppose this is the direction of r. Suppose you have to calculate magnetic field here. So dl, IDL will be along this direction. This is dl. So along this direction is dl. So using vector product we can easily calculate the magnetic field. Suppose this is dl cross r, so inward, so minus k cap. If I take, this is x axis, this is y axis, and this is z axis, so magnetic field it will be minus k cap. Okay, because this is inward. If the current flowing through this direction, then the magnetic field will be along this direction. So in this case the magnetic field will be k cap. So in this way you can easily calculate the magnetic direction of the magnetic field. Now in this case, how to calculate magnetic field? So number one, this is the one side. So this side had length L. Okay, so this is a square. So from this square you can write that this distance will be the L by 2. Now these two angle will be 45 degree. So because this is a square, so this also 90 degree, this also 90 degree, this also 90 degree, this also 90. So it will be 45. So magnetic field at O will be for this AB portion, it will be mu 0 by 4 pi I divided by D. D means here is L by 2. So here it is L by 2 into sine 45 degree plus sine 45 degree. So it will be mu 0 by 4 pi. This will be 2I divided by L into sine 45, this means root 2 plus 1 by root 2. So it will be mu 0 by 4 pi into 2I divided by L. It will be 2 divided by root 2. Now this is my hand, so direction of the I is along this direction and the direction of L is along this direction. So inward, using vector product, you can write that the magnetic field at O due to this A point is inward. So K cap, it will be minus K cap. Okay. Now if you want to calculate the magnetic field for this AD region, the same length, same angle, it will be, magnitude will be remain same, but the direction is also K cap. So all these side magnetic field due to the all side, the direction of the magnetic field due to all side is inward, that means negative z axis, so minus K cap. So total magnetic field B total or resultant must be equals to 4 multiplied by B of AB, because all the direction of all the magnetic field in same direction, that's why it is multiplied by 4. So it will be 4 into mu 0 by 4 pi into 2I divided by L into 2 by root 2 minus K cap. So here it will be this 4 is cancel out, so it will be mu 0 by, this is root 2, so it can be written as pi L, this is I into 2 root 2 minus K cap. Okay, so magnetic field for this region, it will be 2 root 2 mu 0 I into pi into L. Okay, so this is the problem number 1. Now problem number 2 is very easy, similar to 1. So this is the center of mass. So this center of mass, the angle for both cases, this is 160. So this is 160, this is 160, this is 160. Okay. So for this case, this is 60 and this is 60. So you have to calculate this distance. What will be this distance? Okay, so how to calculate this distance? Suppose this is equation number 2. So from this is the portion, suppose this is A, B. So you have to calculate this distance, and total distance, total angle, it will be also 60 degree, because this is a equilateral triangle. So this angle will be 30 degree. So this angle is 30 degree. Okay, now this is, suppose this must be L by 2. So you have to calculate, this is O, you have to calculate this portion, this height, this also a D is called D, this portion. So how to calculate this? So if I take tan 30 degree, so tan 30 degree equals to L D by L by 2. So it will be 1 by root 3. So D by L by 2. So it is D equals to root 3 by 2 L. This is the D. Now using this formula, magnetic field for the AB portion at O, it will be mu 0 by 4 pi I by D. D means this, root 3 by 2 into L. It will be sine 60 plus sine 60. So it will be mu 0 by 4 pi. This 2 will be, this is 2I root 3 L. This is root root 3 by 2, this is root 3 by 2, root 3 by 2 plus root 3 by 2. So it will be mu 0 by 4 pi into 2L root 3 2I, this is L into only root 3. If you add this, so it will be root 3. So this root 3, this is to cancel out. So it will be mu 0 by 4 pi into 2I by L. Now the direction of the magnetic field due to this portion is inward. So it will be minus k cap. So it will be minus k cap, inward direction using vector law. This is I. So I in I cross D. So it will be inward direction. So it will be minus k. If you want to calculate for AC, so it will be also inward. If you want to calculate for magnetic field at O due to CB, so it also inward. So for this, all this magnetic field due to all this side is same direction, is in same direction. So total magnetic field will be multiplied by 3. This is multiplied by 3. So total magnetic field is equals to 3 multiplied by magnetic field for AB. So it will be 3 multiplied by mu 0 by 4 pi into 2I divided by L minus k cap. Okay, this is 2, this is 2. Okay, so you can write that this is 2 2, so it can be written as this is 2 2, so 2 is cancel out, so 3 mu 0 I by 2 pi L k cap, 3 mu 0 I by 2 pi k L. This is the equation for the solve for this equation number, problem number 2. Now problem number 3. What will be the solution for problem number 3? For this portion, so suppose this is D, suppose this is D. So magnetic field for this region, suppose A, B, C, this is D, E, this is F. Okay, so for this portion magnetic field at O equals to 0. So magnetic field for this portion is also 0 at O. So there is a magnetic field due to this portion, there is a magnetic field to this portion. So first of all we have to calculate magnetic field for CD at O. So magnetic field for CD portion, this is CD, this is CD. Okay, so it will be mu 0 I by 4 pi D, this is D. So if I want to calculate theta 1 in terms of theta 1 theta 2, it will be cos, so it will be cos theta 1 plus cos theta 2. So direction, this is I, D, it will be along this direction because this is D. So if you have to calculate the cross product, so I cross D or DL cross D, so along this direction, that means minus k cap, this means inward. And if you want to calculate magnetic field for BC, it will be along this direction, and CD it also along this direction, that means inward. Both the cases it will be inward. So magnetic field for portion BC, it equals to the magnetic field for the portion DE must be equal and in the same direction. So it will be mu 0 by 4 pi into d, it will be I into, if this is theta, so it also theta 1. If this is theta 2, so it will be also theta 2. So from this portion you can write that one angle is 0 degree and another angle is theta. So it will be sine theta 1 plus sine 0. So it will be 0 means 0. So it will be mu 0 I divided by 4 pi d into sine theta 1. This will be for B magnetic field for BC. It also minus k cap. It also, if you want to calculate DC, DE, similarly you can calculate mu 0 I by 4 pi d, it will be sine theta 2, it also minus k cap. So total magnetic field will be, it will be BCD plus magnetic field due to BC, magnetic field due to DE. So if you add these three terms, then the magnetic field at O will be calculated. Now what will be the solution of this point? Here this is a angle 30, this is also angle 30. So magnetic field due to this portion, this is, suppose this is the wire number 1. So magnetic field, this is problem number 4. So magnetic field at O due to 1 wire, it will be mu 0 by 4 pi into I by d into sine, this will be 30 and this is also 30. So sine 30 plus sine 30, and the direction is, this is I and this is D, this is D, so upward. So only k cap along the direction of z axis. I have taken, this is x axis, this is y axis, this is x axis. Okay, so this is k cap, this is k cap. So it will be mu 0 by 4 pi into I by d, sine 30 sine 30, half, so it will be 1. So this is k cap. So magnetic field due to wire, this is, suppose this is wire 2, it will be mu 0 I by 4 pi, this will be 2d into sine 30 plus sine 30. So the direction of the magnetic field is along this direction, so negative k cap. So negative z axis, that means negative k cap. So in this way you can calculate that mu 0 I by 4 pi d into 2, this will be 1, so it will be minus k cap. Similarly, suppose this is 3, so magnetic field due to wire 3, it will be mu 0 I by 4 pi into 3d, it also be sine 30 degree plus sine 30 degree. The direction of this wire, this is along this direction, current through this along this direction, the magnetic field, direction of the magnetic field will be k cap. So it will be mu 0 I by 4 pi into d into 3, so it will be k cap. Similarly, if you want to calculate B4, this is suppose 4, so it will be mu 0 I by 4 pi d into 4 into, it will be k cap, because this is A, this is D, so along this direction, so this is k cap. So what will be the total magnetic field at O? So magnetic field total at O is equals to the summation of this magnetic field. So mu 0 I by 4 pi d, both are common, so it will be 1. For this here it will be minus 2 minus half. For this portion it will be 1/3. For this portion it will be minus 1/4, and so on. And this will be k cap. K cap. Okay. This is along the direction of k cap. So it can be written as mu 0 I by 4 pi d. This is can be written as ln 2 k cap. So this is the magnetic field at point O due to this arrangement. Now problem number 5. What is the problem number 5? So this is, suppose this is A, this is B, this is C, and this is A dash, this is B dash, and this is C dash. So magnetic field due to this portion at O and magnetic field due to this portion at O is equals to 0. So for this portion is 0. For this portion is 0 at magnetic field at O. So this is half infinite wire, this is half infinite wire. So magnetic field due to AB, it will be mu 0 by I by 4 pi, this is distance r, so this is r into sine angle and another sine angle. So sine, one angle is 0 and another angle is 90 degree. So if the angle from this portion is 0, so this is infinite. So if we want to calculate the angle from infinite to this action, so it will be 90 degree. So it will be 0 and it will be 90 degree. So it will be mu 0 I by 4 pi r into 1. So direction will be, this is I into a inward, so it will be minus k cap. So if you want to calculate the magnetic field for A dash, B dash, it will be similar, mu 0 I bar 4 pi r, but the direction is also, this is I, okay, this is I and this is r. So this is the direction, so it also inward direction, so it also minus k cap. So total magnetic field is equals to 2 into mu 0 I by 4 pi r into minus k cap. This is the solved number 5. Now for this case, so if this is the problem, so it will be, what will be the relation of this condition number 6. So problem number 6. So current will pass through this portion and current will pass through this portion. This will be half I, this will be half I. If I want to calculate the magnetic field for this upper portion, the direction of the magnetic field will be inward. For the lower portion, direction of the magnetic field will be downward, upward, and this is inward. So magnetic field for this portion, direction will be inward, and for this portion, direction will be upward. That's why the net magnetic field will be 0. So for this case, number 1, magnetic field at O equals to 0. In this case, suppose current will divided in this way, because this is wire, this is wire. This current will pass, more current will pass through this and less current will pass through this. But the direction of the current for this region is inward and for this region is upward. But the magnitude will be remain same, because current will pass through this wire is less and current will pass through this portion is high. For all these cases, so here is for this region number 2, it will be magnetic field equals to 0. So similarly, all the cases, if you look all the cases, the magnetic field of at O it will be 0.